I'm going to show you how I built an AI model that gives suggestions on how to plan for events using Python and the transformer model. So you might be wondering, why use a transformer model? Well, it's not because it can turn into a cool car or a giant robot. No, the transformer model is a type of neural network architecture that's been a game changer in natural language processing. It's the same technology that powers chatbots and translation services. So buckle up and let's dive in. First, we need to import the necessary libraries. We're using the Transformers library from Hugging Face, which provides us with pre-trained models for various tasks. So over here, we're importing the GPT-2 tokenizer and GPT-2 head model from the Transformers library. The GPT-2 tokenizer will allow us to convert our text inputs into a format that the model can understand, and the GPT-2 head model is the actual model that we'll be using. Next, we load our pre-trained model and tokenizer using the from_pretrained method. This method downloads and loads the weights of a pre-trained model. In this case, we're using the GPT-2 model. Now we define our event. This is just a string that describes the event we want to plan. We then encode our event into a format that our model can understand using the tokenizer's encode method. This method converts our text into a sequence of integers, where each integer represents a specific word or character in the model's vocabulary. We also convert our input into a PyTorch tensor using Torch tensor. A tensor is a multidimensional array of numbers, and PyTorch is a library for processing these tensors. It's what allows us to perform complex operations on our data, like training our model. Next, we set up fine-tuning for our model. Fine-tuning is a process where we take a pre-trained model and train it further on our specific task. In this case, we're using the AtomW optimizer with a learning rate of 1e5. The optimizer is what adjusts the parameters of our model to minimize the loss. The loss function measures how well our model is doing on its task. In this case, we're using the same tensor for both the input and labels, which means we're asking the model to reproduce its input exactly. This is known as an autoencoder setup. Now that everything is set up, we can generate our plan. We use the generate method of our model to produce a sequence of integers representing our plan. The max_length parameter controls how long this sequence can be. Finally, we decode our output back into readable text using the tokenizer's decode method and print it out. And there you have it, folks. This is my journey in creating a simple AI model that suggests plans for events. The beauty of this model lies in its flexibility and potential for expansion. You could customize it further by adding more specific prompts or even integrating different models. The possibilities are truly endless. But for now, that's all from my side. Until next time, keep exploring, keep learning, and remember, the future is AI.